let's say that we want to keep a good manner for the fraction. We don't want to see like 1.2 over 3.5, a fraction like this, which is very complex. Well, I don't know what is okay, 1.2 over 3.5. That's just not a nice number. Like, we don't like it. So in the VC requirement, we require for method and special, we all required the denominator must be an integer. Okay, denominator must be an integer. So that's why we have this exercise, rationalize the denominator. So your denominator needs to be an integer. So for example, this simple example here, 1.2 over 3.5, that's easy to achieve integer. So it's just 12 over 35. I can enlarge that by 10 times to make it like a denominator. Integer. But like if you can see what we do last lesson, this equation, like we have answer 5 over 3 root 3. This is just very good example to show I need to rationalize my denominator. My denominator is an irrational number. Like we know that square root, cube root, they're all irrational number. So we have an irrational number. We need to rationalize it, make it become a rational number. Also, it needs to be an integer number. So what I can do to get rid of that root 3, make it become an integer here. That's what we're going to learn today. So just choose this as an example. Just choose the first one as an example. If we just have a single root, like square root at the bottom, I can just times exactly the same thing. Why we time exactly the same thing? The same square root times together, you will just have the number inside. I can get rid of the square root. Well, I can't just times the root 5 at the bottom. I also need to make a balance. Time a root 5 on the top to make the number like to become the same. So root 5 over root 5 is just a 1. It seems like change nothing here. But if I can just times that, the top become a 3 root 10. The bottom become just a 5. Okay, root 5 times root 5, we just have a 5. And top is a 3 root 10. Okay. Well, let's do another example here. Okay, if we can see a 5 root 2. Okay, last year when I teach like the previous class, they trying to time 5 root 2 on both top and bottom. It's not necessary. Well, you can. It's just not necessary. Why it's not necessary? I just want to get rid of the square root. It's nothing to do with the 5. The 5 and square root 2 is a 5 times square root 2. What I can do is just times another square root at the bottom. At the same time, I will times square root on the top as well. Okay, times the square root on the top as well. So that's a 2 root 12. And the bottom is just a 5 times 2. Because root 2 and root 2 give you a 2. So 5 times 2. I'm not going to times the whole denominator. What I will do is only times the root. Okay, the root. What root I have, I'll just times by that. But it's not good. Well, you can see I can get rid of this 2 and this 2 here. And also the 12 is a 4 times 3. Okay, a 12 is a 4 times 3. So the top can become a 2 root 3 and the bottom is just a 5. I need to simplify it to the simplest version. Okay, so no common factors from top and bottom. So I can cancel the 2 and also root 12 needs to be simplified. Okay, let's have a look at this one, the right corner one. This is a very interesting example. As the number are very large, okay, the number are very large, I'm not going to time root 70 on both top and bottom, because what I can do is, the top is a 7 times root 9 times a root 10. The bottom will be a 2 times root 7 times by root 10. I can cancel the root 10 and root 10. I can get rid of anything when you have like top and bottom, they both have the same factor. So the root 10 just gone. I have make the numbers a little bit smaller, okay, which is much easier to deal with. And then we can see the top is a 3 times 7, 21, over 2 root 7. So I will times root 7 and root 7 on both top and bottom. Okay, you need to know the purpose. My purpose is just get rid of the third. I want integer at my bottom, like as my denominator. So I must get rid of that. So that's a 21 root 7 over a 2 times 7. So the 21 can become a 3 and the 7 can become a 1. They can get simplified. So is a 3 root 7 over 2. It's a 3 root 7 over 2. Which one? This one? You just separate it. And then times root 11 on both top and bottom. Okay, so the first page is like either a really simple third at the bottom or like a 5 root 2 something with a number in front. So the way we do it, we just time top and bottom by the same third as the bottom and then rationalize that. But if you can have a look for the next page, well, if you have like not a single number at the top, so I have 1 plus root 2. Okay, I have 1 plus root 2. So what I can do is still times root 3 and root 3, but the top is with a bracket. Okay, the numerator will be with a bracket. So what I will have will be root 3 plus root 6 over a 3. Bottom is root 3 times root 3, that just becomes a 3. And then you expand the bracket on top, root 3 times root 6. Sorry, what? Oh, plus, yeah. Plus root 6. There's a like really common mistake, but I think when I say it, everyone knows that's wrong. But when you do it, you will. When you do and the test condition is very easy to make such mistake. Like for example, root 2 times root 3, it's very easy to write as a 6. When you say 2 roots and you're trying to get rid of it, like I see quite a lot of mistake like that last year. Like students doing something too quick and they under pressure and time pressure, they just root cancelled. Well, it must be the same roots. They can cancel each other. Otherwise, they can't. Okay. So something I mentioned now, you think, oh, so easy. I won't get it wrong. But maybe you will get it wrong under like the time pressure. Let's have a look at the third line. When you're trying to add two fractions. Any questions there? Any questions?
Wait, can you just repeat what you said about
Any?
so if you go back to the question you just did, you can't simplify the
No.
no, you can't add them. Because then you
They're not the same. Like root 6 can't become a root 3. Like you can just stay as that. If it's a 3 root 3, then we can add it together. Yeah. Okay, let's have a look at that one. Let's do a complex one, like the middle one here. Okay, the middle one here. So when you have two fractions and they are not rationalized denominator yet. So we need to make the denominator rationalized first and then try to make the same denominator and then add it. So let's do step by step. The first one, I will times root 2 on top and bottom. Just write it better. And then the next one will be root 3 times by root 3. Okay, to rationalize. It's not adding yet, like nothing to do with each other yet. Just trying to make the form looks a little bit better. You can't add them. You can't add them in this form. You must have the same denominator and then add, right? Well, you can. So what's the same denominator you're aiming for here? It's hard, like you can. Well, I will say I will aiming for a 12 root 6, but like it's very hard to achieve. Like it's very hard to achieve. So, and then you still need to rationalize it, and you need to think a long time, like what's the common denominator should be. So, I would rather just get it separately rationalized first and then adding them. So, what I have here is a root 2 on top and 6 at the bottom. Root 2 is a 2, 2 times 3 is a 6. And then we have 5 root 3 here. 4 root 3 is a 3, so that's a 12 here. Now just times the first one by 2, 2 root 2 over 12 plus 5 root 3 by 12 over 12. And then 2 root 2 plus by 5 root 3 over 12. I can't simplify that further. Root 2 and root 3, they are different. I can't add them. Also, there's no common factors. I can't cross that out. Like, I can't cancel with anything at the bottom. For adding or subtraction, like you must have the same denominator in order to add the numerator and like keep the denominator to be the same. So why we rationalize that first is because I can't find the common denominator under this form. But I can, just very hard, and it's not the simplest version as well. So I will just recommend to rationalize first and then make the same denominator and then adding them. Do you have any questions? Okay, so the next one will be the same. And then another type we'll have is like this. Okay, before we just have a single third number at the bottom, so whether 2 root 3 or 2 root 5 or root 4, root 3 or root 10, like it's a single root. But now we have like two terms, like a subtraction. Something subtract something or something add by something. In this case, well, it will be in your test, okay? I'll just let you know, it will be in your test to rationalize denominator like this. It's very important. We need to use the difference of perfect square formula. Okay, that's what we learned yesterday. A plus B, A minus B will equals to A squared minus B squared. That's what we'll use for these questions, okay, for this row. Why we need to use that? Let's have a think. For example, the first one, I have a root 7. I have a root 7. I can't times root 7. Because think about if I times by root 7, the 6 will times with the root 7 as well. It's still irrational, okay? Or let's say we times by 6 root 7. It's still not working. You still have a root 7 there. So you can't really use the previous method, like say we find the same third and then times it. Or for that one, I can't times by root 11 or root 2. If I times by root 11, the root 2 can't get cancelled. If I times by root 2, the root 11 will still stay there. Only the 2 will become an integer. So what we will do is we use this formula. So this one we can treat as a minus b. So what I will times, it will be a plus b. Okay, so I'll bracket everything. We just times the other version. If you have a plus b, then you times a minus b. It just depends on what you have. Yeah, it just depends on what you have. And then the top become 7 times by 6 plus root 7. And the bottom, okay, that's a minus b times by a plus b. That's a 6 squared minus root 7 squared. Okay, that's the formula we used yesterday. So then after that we just expand. Can you see we square both number? We use a formula to square both number. If we square both number, both third will just get rid of both third. So 42 plus 7 root 7 over 36 minus 7. Yes, 6 squared is 36. Root 7 times root 7 is just a 7. So that equals to 42 plus 7 root 7 over 29. The denominator is a 29, and that's an integer. Okay, just show you another example. Let's just do this one. Let's do the last one. So 4 over root 3 plus root 7. What we have here is a plus b. Then what I need will be a minus b. So I will have a root 3 minus root 7. Root 3 minus root 7. So, okay, they all in the bracket. Okay, it's all times relationship. It's all in the bracket. So, we have 4 times by root 3 minus root 7 over root 3 squared minus root 7 squared. Okay, do not expand yet. Let's just have a look what the bottom looks like. 4 root 3 minus root 7. Then it's a 3 minus 7. Okay, root 3 squared is a 3. Root 7 squared is a 7. And then we have 4 root 3 minus root 7 over negative 4. Over negative 4. Yes. Well, you can keep it. Well, I will tell you why I want to keep it. Because I can get cancelled. I can see there's a 4. Because when I see the bottom line, I I will create a 4 out. So that's why I said I'll keep it first. Do not expand because it will go in the end. I know that. So if you can see it, you can keep it like that. But if you expand, you need to think about the cancellation later as well. Okay, you can think about the cancellations as well. So that's 3 minus 7 will give you a minus 4. So this minus 4 and this 4 will get cancelled and you have a minus 1. So the denominator just become a 1. And then the numerator is just a negative 1. So that will be a negative root 3 plus root 7. Then we expand here. Well, I can say that's a root 7 minus root 3. That will be the same. Well, you can definitely expand it like immediately, but I will suggest you keep the factorized form until you work out what your denominator is, and then see if there's a common factor I can cancel. If I don't have, I can just expand it. If I have, just keep it in the end and then do it. Okay, any other questions? I have to go through 1 or 2 examples for each type of these questions. This exercise is not hard. It's just like, don't make calculation error. Okay, just don't make calculation error. It's very easy to make calculation error. Basically, there's only 2 types. One type is with 2 terms, like a plus b or a minus b at the bottom. And then one is just with a single third, like 3 root 5 or 5 root 2, something like that. We just need to choose the correct method to do it. Okay, if you don't have any questions, please complete this 2 pages. And then if you still have time, just work on some of your homework, please.